Okay, now everybody remembers this as soon as I do it. If you reviewed your notes properly, and then, I say, review the notes within, as soon as possible after class, hopefully within at least a few hours. Because otherwise stuff starts getting away from you. And then review them again the next day. Even if it's between Tuesday and Thursday, and it was now, and I know that with the test and all the other stuff, it's hard to even bring yourself to spend 15 minutes doing something that doesn't immediately save your life. Okay? I understand. I've been there. Everybody has. Okay? Okay, well, anyhow, you should review it that day, the next day, and before you come to class. The first review, 15 minutes. Second review might be 3 minutes. Preferably longer. Okay? But, if you're under pressure, just make yourself stop for a minute, look at your pre-calculus, and then go on. And before you come to class, look at it. Okay? Then you might remember more clearly what we do. And now, since I drew this, everybody told me what to do. Go jump in a lake. No. And who would blame you for that? Now, for telling me to go jump in a lake. No. Well, I wouldn't blame you for jumping in the lake, although this time of the year probably isn't great. Right? We put our zeros on the x-axis. Dividing it into what? Just a little terminology.
Intervals.
Intervals. That is what you said, isn't it? Mm-hmm. Yeah, because I heard 3 syllables. Okay, so how many intervals do we have? 3. Okay, everybody agree?
Yeah.
1, 2, 3, 4. Yeah, you're right. Okay, well, there are 4. There are 3 points. That's going to divide the x-axis into 4 intervals. 1 point divides it into 2 intervals, and every point you add divides it into another, unless one of those points is the same as one you already have. And that's going to occur on one of these. Okay? Well, that's coming up, so kind of store that away. Okay, we divide the thing into intervals. And we know by the intermediate value theorem, which everybody's aware of, right? No. Okay, it's the first time, I kind of mentioned it last time, but I didn't say anything. We know by the intermediate value theorem that this function can't change sign unless it goes through 0. It can't go from negative to positive without passing through 0, right? Okay, that's not necessarily true of all functions, but certainly for polynomial functions, it is. Okay? Like, x minus 3. Can x minus 3 go through 0 without being, can x minus 3 change sign without becoming 0 at some point? Well, the graph of x minus 3 is just a graph with positive slope, right? And there's an x-axis here, and it goes from negative to positive when it crosses the x-axis, right? Okay? That's very important. I'll keep mentioning that. The intermediate value theorem says now I've got to go back to really formal mathematical terminology. You can't go through 0. I'll change sign. Yeah, I'm getting all confused by the uppity language here. You can't go through 0. You can't change sign without you go through 0. Okay? I know. I know.
Sophisticated.
You're totally impressed by my erudite delivery, right?
I like things dumbed down, so this is good.
I'm sorry, dude.
I like things dumbed down, so this is good. I can understand it.
Yeah, well, see, now when I do this, really what I'm trying to do is I'm trying to pull you out of your stupor and get your attention, okay? Because I know I put you in a stupor, 30 seconds after I start talking. Now, okay, you understand what this is saying, right? Maybe you'll remember it. Maybe you can think of an even better way to phrase it, okay? Work on it. Put that into your homework. I'll read it. I'll give you a comment, tell you whether I think you've done good. done good, I'm sorry. Okay. Okay, well, what this means is that if you take any number in any of these intervals, you can determine whether the function is positive or negative on the whole interval. Now, that's not what we did last time. Last time we looked at the value here and the value here, okay? We said, well, if it goes from this value to this value, it stays negative all the time, or it stays positive all the time, right? Well, you want to understand that. Yeah, that's very basic. This is a little more sophisticated, especially the way I phrased it. This is kind of the way we're going to talk about it, but it means exactly what we did last time, okay? Not exactly. I mean, this is actually something you got to prove in a mathematical analysis course. I mean, like a high-level analysis course you take after you've had 6 semesters of calculus, okay? It's a pretty sophisticated result, really. But we can use it. There are restrictions on what kind of functions that applies to. Okay? And there's another. So, really I should say a polynomial can't do this, okay? Any continuous function can't do it, but you don't know what a continuous function is. So. For polynomials it's true, for exponentials it's true, okay? What basic functions would it not be true for?